So you're welcome back to a session with Edu Ada. We spoke about work, energy, and energy in the last video. So we continue with power. There are three brothers that are very, very useful in science. So we have power. We spoke about energy to be what? Energy can be equal to force times distance with respect, that is, the force being applied to a body in a given distance with respect to time. Of course, that force will be applied in the direction of the force is applied to that body in a particular distance and in the direction of that force, the direction of the application of the force. Yes, and we also define work. That's what we define work to be. Work is said to be the one the force is applied to a body in a given distance with respect to time. While energy is the ability to do work. Well, both of them are measured in joules. And if you have it, you can also have it in kilojoules. But now we talk about power. Power is defined as the rates of doing work or the rate of energy transfer. It can also be said to be the rate at which energy is expended, which means if there is no energy, there is no power. So power is being produced as a result of energy with respect to time. Yes, so they are trying to measure the rate at which amount of energy is being consumed. They're talking about power, and power is measured in watts or joules per second, and your watts can still be measured in kilowatts. So if you have power, you use the black, can denote power to be equal to what? Power is energy upon time. Don't forget, energy is measured in joules and your time is in seconds. That is why we say power, the unit of power is joules per seconds, or you just use watts. Is that good? So that is what we have power to be. Let's continue. If you have, okay, let me give you another definition. Let me expand something. If you have your work done, we said power is energy over time. That is work done, force times distance. Work done is force times distance divided by time, and this can still be equal to the force times distance over time. Is it not the same thing? And this can also still be equal to the force times, what is distance over time? That's velocity. So FV, force times velocity of a body, because distance with respect to time is like speed. Just leave that unit of distance, because velocity we have to deal with displacement with the direction. So we can still use it. We have force times distance over time can be written as force times then distance over time. Splitting is applicable, is allowed in mathematics. Then you have force, because velocity is what? Distance covered by a body, or in respect to the direction, distance covered by a body with respect to time taken by that body in a given direction. All you have it to be force times velocity. So we can work with this. Let's solve our examples quickly. Yes. Solving our example, let's start with example 1. Example 1. Okay, I intend to give some other formulas for power. There are some other, if you are dealing with power, You can deal with power in different forms. What are the forms? You can have power to be equal to power. I said it can be the energy F times distance over the time taken. Power can also be equal to, of course, your work done over time taken. You said that it can also be equal to QV over T. Where do I get QV? So we are working with respect to electricity. Talking about the energy and power in electric cables. So we have this is quantity of charge. It's measured in coulombs. Then is the potential difference across the ends of that electric conductor, and this is the time. And it can also be equal to IVT over time. Of course, power is equal to current and voltage times time. But since it's divided by T, this cancels this, and this can just be equal to IV. Are you getting that? It can also be equal to another thing. You can have it to be equal to I square RT divided by time, of course, because this I square RT is your energy flowing in a conductor, a metallic or an electric component. So the same thing with IVT, but because it's energy, then this has to be divided with time, just respect to time. So this can cut this again. We are having it to be equal to I square R. Are you getting that? And that can also be equal to what? This can also be equal to V square. I have it as V square. V square R. Yes. V square R. V square R over R square. So we have V square R over R square, and that can be equal to V square. This R, we cancel one of this R, one R will be left, divided by R. So let me stop there for the other things you can have in form of power. Let me give it a stop there. Then we go to our examples. What are the examples? We have example 1. Let's deal with example 1. Deal with example 1. What do you have? Example 1 states that it says the engine of a train produces a force. Now in science we write out the parameters. We have produces a force F is equal to 3000. 3000 newtons when moving at what? 30 meters per second. Of course, this is our velocity. I say that power is equal to work done divided by time. That means force times distance divided by time. And that can also be equal to force times velocity over time. Sorry, distance over time. And distance over time will give us velocity. That means force times velocity. That will be equal to power. So V is 30. And it is calculate the power of the engine. Power is straightforward. Power is force times distance over time taken, and that's also the same thing as force times distance over time, and that is also the same thing as force times the velocity, and that is equal to what? Your force is 3000 times 30. So that can be equal to 3 times 3, that is 9. How many zeros? That's 9 times 10 raised to power 4. And that is equal to 90,000 watts. Power is measured in watts, and that can be equal to 90 kilowatts. The 1,000 stands for kilo, so kilowatts. That is done. Example 2. Quickly, we have example 2. Now example 2, the question says a machine of efficiency is the efficiency. The efficiency is what? 80%. Is used to raise a body of mass. The mass is 75 kilogram through a vertical height, that's my S, distance 3 meters, in you have T to be 30 seconds. Calculate the power input. You are giving G to be 10, of course, that is 10 meters per second square. There should be a square here, so sorry about that, it's a typo error. So that is 10, and it's a square here. Yes. So you are told to calculate the what? The power input. Now, power efficiency itself, efficiency, let me write it in full, is in percentage, of course, is equals to power output. Power output divided by power divided by power input. So this is the formula I use, times 100. Times 100 over 1. That's why it is known as efficiency. We will use this in a lot of aspects in physics. So you need to know what efficiency is. If you are dealing with transformer, you do the same thing. But yes, power output or power input times 100% times 100, that is your efficiency. If you are dealing with machine, you deal with mechanical advantage or velocity ratio times 100 over 1, that is the efficiency. So and more and more and more. So if you add this now, we do with what's our power output. I think we can calculate our power output because this body is of mass. This, don't forget, power output is denoted by P naught. Let me note it here. P naught. While power input is denoted as P1, just for ease. So P naught will be what? Power means what? Mass. Force times, okay, let me start from force. If there's no energy, if there's no work done, there's no power. So we start with work done. Power is produced by work done, and work is what? Force times distance, isn't it? That is what work is, then divided by T. Don't forget, this can also be equal to our force is mass mg. Here, because they give us g, our acceleration due to gravity of the body, mg. That is what f is. Then distance, which is I denoted by s here, so let me write s here. Then divided by time. So that can be equal to what? We have 75 times 10. What's the distance? The distance is 3 divided by the time is 30, isn't it? So since the time is 30, 0 cancel out this 0, 3 here 1, 3 here 1. So what we have here is 75. That's the power output. So since we are looking for power input, we are given efficiency to be 80. Very good. So we can say 88. Efficiency can be already be equal to what? P naught. P naught is already given as 75. So 75 divided by what? What's our power input? Which we don't have, P1. Can you see that? Then times 100. Can you see that? So we have P1. Our power input can be equal to 75 times 100, everything divided by 88. What do we get? Let me check, punch my calculator. I have that be 7,500. 7,500 divided by 88. So I have 85.2. 85.2 watts. That is what our power input will be. Don't forget, this is our power output, the carry watts. So thank you very much for watching. Please don't forget to keep subscribing to my channel. I have a lot to give you. So we have 081. You can reach me on this number for any observation, for tutoring, physical, online. I'm always available. 08164 86 94. Then you have 70. Thank you for staying with us. See you next time.